Hello. I think it's interesting that not only were both submissions here from Canadian companies, but they were also both related to geohazards, and I think that speaks to Inspire being a international, but cross-continental and very focused on environmental applications. So Minerva is a company. We're based in Vancouver, but we've also just recently opened an office in Darmstadt in Germany to kind of facilitate our business here in Europe. And the team for the project was a good representation of who Minerva is. We had some software developers, a big GIS team, and then also the experts in the specific field for this. It was landslides. So we had Gio Roberti, our section head of geohazards, representing that. And Minerva is really focused on bringing human intelligence combined with machine intelligence to produce predictions. In this case, what areas are susceptible to landslides. I'll just give a little kind of preview of what the web app does, and then we'll do a demo at the end if I have some time. You have 3 different primary layers, which are the susceptibility maps for the different landslide types. So you have debris flow, slides in soil, and slides in rock. For debris flow, as shown here, it's a buffer around the stream because debris flows happen in streams, while the slides in soil and slides in rock is a more continuous vector polygon data set of slope units, which is half of a watershed. And then by clicking on any feature, maybe one that has a higher ranking, so is either red or purple in color, you're going to get a pop-up, and it's going to tell you some of the primary attributes of that location, of why it's susceptible to a landslide. And then you can kind of drill down further and get a full explanation of how we got to that susceptibility ranking. So what you see on one side of this chart is a description of the model, so a conceptual model of what a debris flow looks like. And then you have a description of all the attributes that we know at that location and which ones are matching. And I'll get more into how the explanations work in a bit. But the other aspect of the web map is that you can actually click on any of the highest ranked polygons, so the polygons that are in purple. It's hard to see here, but in the bigger polygons it's easier. And then you can show different simulated landslide runouts. So we have different landslide classes. Right here I think we're showing a class 5 debris flow, and you're seeing where the sediment would accumulate. So the use case for Inspire, I don't have to tell you guys about interoperability, but when we talk about interoperability, we're not talking just about the data structure. We're really talking about the semantics that are underlying that, because that's what's important for a reasoning system to work and be reusable, so that this application can be done in Veneto and then brought to other regions in Italy and to neighboring countries that also have landslide problems like Switzerland or Austria. So yeah, it's really about a streamlined workflow where the semantics that are in the data are standardized so that we can align our models to that data and then use any Inspire data. For the project, we started collecting data. We didn't want to have to do this step, but there's really very limited Inspire data in Italy. It's too bad, but we overcame that challenge by just aligning the data ourselves. We did that in Hail Studio, and that didn't take too long. And then we did some spatial processing where we had our units of analysis and attributed them with all the input data that we had. Then using our internal AI system, we calculated the susceptibility and then presented the map or the results in a web map. Throughout that process, we realized that we had to extend some of the concepts in Inspire to meet our needs for the project. And so I'll talk about that now. One of the first things that we did was to look at the natural hazard classification code list, and we realized that it ended with landslides, so we wanted to extend that so that we could talk about debris flows and soil slides more specifically than just a generic landslide. So we did that by taking the VARN's updated classification of landslides and we put it into a tool called ACE. That's an open access tool that we provide, which allows you to specify the properties of classes, and it'll infer a hierarchical structure for that code list with free of any logical inconsistencies. So then we took that structure and put it into our registry so that we could have that all formally done through the Inspire registry, our own Inspire registry instance. So you can check that out at minerva.codes, and ACE is available there as well. So the other thing that we put into our registry was some of the feature types that we put into our schema extension. When we were looking at the natural wrist zone schema, we understood that what we were doing was slightly different than the way that Inspire talks about hazard. So we wanted to add a concept called susceptibility, which is really the relative spatial likelihood and has nothing to do with the temporal aspect. So we understood, perhaps wrongly, but that the hazard area, when you're talking about likelihood of occurrence, that's a likelihood with a temporal aspect. What we are calculating susceptibility area, that susceptibility is just relative to its surroundings, and it does not have a temporal aspect. We're not saying this landslide is going to happen within this many years or something like that. So for the susceptibility area, one of the elements was influencing factor. So that ties to the information that we know about the location that is influencing whether that landslide is going to happen or not. So for the project, we took some Inspire data, or we aligned some Inspire data. Most of it came from the Veneto geoportal. The land cover came from the Korean data set. And all these are fairly standard for landslide hazard assessment or susceptibility assessment. Once we had those input data sets, we created our units of analysis, so our stream buffers and our slope unit polygons. And then we attributed all the input data to those units of analysis. And then what we do is we convert those spatial features into semantic networks, so into linked data, because our internal reasoning engine works with linked data and is able to get some of those benefits of linked data that Bart was talking about yesterday. So I wish I had way more time to talk to you about how our reasoning engine really works, but I have to be kind of brief. So in this particular situation, what we were doing was we had a set of different models. So the debris flow model, the slides and soil model, and those are conceptual models. And we're comparing those to the features, the spatial features, the polygons, the slope unit polygons that have been attributed with the input data. And what we do when we compare those is we end up with a similarity score of how similar the model is to that location. And so sometimes we have exact matches where the term that we're looking for is found within the instance, but sometimes there's more complex relationships, such as a kind of match, which would be when we're looking for one thing in the model, but we have a more specific term in the instance. So that's making use of the hierarchical code list structures that are found in Inspire. And this matching process is really constrained by an ontology, which allows us to link those code lists to the actual properties in our features that we're talking about. So once we've calculated the similarity score, we represent that as susceptibility. And for the polygons that have highest susceptibility, we calculate a runout for those. So we do a landslide runout simulation for different landslide classes. And then we present this all in a web map. And what we also did was we aligned all our different maps to the schema extension and the natural risk zone schema, and made that available as GML. For the project, we used some different tools. We used AvaFlow to do our runout simulations. We used a tool to calculate our slope units. these are just some of the more important ones. For all the input data sets that we were aligning, we aligned those using Hail Studio and Hail Connect to actually serve those into our web map so that we could actually visualize the complex hierarchy that is present in some of those data sets. And the web map was done in open layers using the Boundless SDK, although we updated the Boundless SDK to the latest version of React, and that gave us a huge performance increase. And the whole thing is hosted on the cloud using the Azure Kubernetes service for scalable applications. How am I doing on time? I think I can give you a good demo because I ran through that faster than I was planning on it. So this is the website where you can find a lot of the content that we've put on the report that we handed off to the JRC, but you can also get to the map from here. So when you open the map, you have a bit of a warning, kind of standard information about what to expect to get from this map. And here are your main debris flow slides and soil and slides and rock layers. And then you can go and find a polygon of interest to you. The purple ones are the ones that are the highest ranked, so I'll bring up the legend here. And those are the ones that have been simulated for their runouts. So if we click on this polygon, we can show the different classes of runouts. And then we can also see the match report, which, so here, this is basically a description, although this is stored internally as a linked data set, as a semantic network, we're representing it here as a table. So it's saying that a rock slide has the geomorphic process mass movement, and in the instance from the landslide database that we got from Italy, we know that there have been rockfalls in the past. So what we're doing here is, even though we have rockfall and we're looking for mass movement, we're still awarding the points, and that's because a rockfall is a kind of mass movement, and we know that because of our code lists that we're using internally. So yeah, these are where you can get links to the explanations for why those are why the points are being awarded. Another thing to note here is that all of in the model, all of the nodes are being represented with a frequency qualifier. So our experts say that a rock slide always has mass movement. So you see that term always, and that'll affect the score that we're giving it. Whereas when there's only flows in soil, sometimes that is awarded a lower score in terms of calculating that susceptibility ranking. So this is really making use of the linked data and taking Inspire because of its hierarchical structures and making use of that structure and taking some of those benefits that you can get that Bart was talking about yesterday. On the web map, there's also all the input data sets that we used. Some of them are coming directly from Hail Connect. So you can actually take a look at the Feature Explorer and see that for this unit, we have 3 different rock types that are found in that polygon, and we get to represent all of those rather than in a simple structure, only being able to say that there's, in this case, we would have to go with sedimentary rock or something like that. Yeah, so feel free to take a look at this. Take a look at all the different layers, and obviously you can change what base map. It's fairly standard web map. I think I do have time, so I'll quickly go to minerva.codes and show you what we've done there. So this is the registry that we set up for the project. And so you can see that we have a code list. Here's our landslide extension for the natural hazard category. And so we actually added all 48 terms there, even though we were only using a few of them. And the top level terms connect back to the Inspire registry. That was something that we learned throughout. I was mistakenly convinced that you had to actually recreate the entire code list in the registry, but I was happy to find out that that was wrong and that you should only have the extended terms with the terms above that connecting back to the Inspire registry. I think that's it. Any questions? Yeah, Dean, go.
Quick question. So, how much of your data was, let's say, European? Like, did you have to translate from Italian? And
Some of the data sets we did have to translate to Italian.
Additional Italian code lists.
Yeah. So we translated most of them to the English code list. If you look at when we're on the website, some of the things we left in Italian. So I think that if some of these. All the terms that we used in our matching or in our reasoning engine, those were all done in English, but we're still providing in the database the original Italian. And which data set is it? I think it's the soils data set. You can see here that we have, if you click on these, the descriptions are still in Italian. But luckily, we have an Italian working at the office who was able to do those translations.
So you translated the labels of the categories to English.
Yes.
And then did the inferencing and the code lists were done essentially in English.
Yeah.
With the data post translation.
Yes.
Yeah.
No other? Yes. Go ahead, please.
Well, we already discussed a little bit that we have some issues with the extension model, but first of all, congratulations! It's really very good application and the use of Inspire data. I just wanted to say that this team is really a scientific team. The natural hazard is a scientific, and as you said, it's really about semantics there.
Yeah.
And the team in Inspire, the National Risk Zone, it's called. The main objective or the main power is that it combines all different types of hazard. So it's not meant only for floods. It's meant for earthquakes, for heat waves, you name it. And therefore the basic three concepts that are in the model, so hazard, risk, and exposed elements,
Yes.
they have to be how to say followed, no? Because otherwise the whole concept will not work. So when you were introducing a new concept of susceptibility, which is there, that makes the difference.
So I'm gonna say my point on that, because I agreed that. Well, here's what I think is that when we're talking about hazard, there's the element likelihood of occurrence. Our understanding and our purpose was really to make this applicable to any hazard, whether it's flood or earthquake. And what we were considering of a hazard area was where that event would impact. So I'm not going to use landslide example. For a flood, the hazard area would be where that flood would extend the banks of a river, whereas a susceptibility area would be with the confinements of the channel and would discuss whether or not that river would flood or not. So when we're talking about susceptibility, we're not talking about where that's going to impact. For us, that's a runout zone. We're talking about the source of that event. So I mean, we might have been wrong, and I'm here to talk to you about what we did and not what we should have done. But our understanding was that our concept of susceptibility was distinctly different from hazard.
I said it just because there is a follow-up session now on Inspire Forum. And this is exactly the place where you publish your interpretation of things, how you think should be done, and you basically compare it with other peers of the domain, whether they see it in the same way or not. So that's why I asked this detailed question, which I think we don't have time to continue, but just.
Well, we'd be happy to discuss.
Yes.
And I think that I'm in this context, I'm speaking for my colleague Gio, who is the one who really designed the schema extension. I implemented it, and so I think he should be there in that conversation. Yeah. Thanks. Oh,
I will say there's a third category there as well, which is risk.
Risk is
there as the value of the buildings and how many people.
Yes, and that's linked with exposed element. Yeah.
Have you any idea of making the same exercise in other countries? Or?
Yes, definitely. This is just a start. We would love to, be able to fund these projects, but we're looking at definitely extending it within Italy because we already have that data quite available, but definitely looking at other countries as well. And there's a similar application that we've done in Canada in the area surrounding Vancouver. So, yeah. Thank you all.